Hello, how are you doing today? And welcome back to Emoji Comedy channel. It's nice having you all around once again. In today's lesson, we're looking at indices. I know you must have heard about indices before. Indices, logarithm, blah blah blah. And if you've not heard about them before, then it's okay. So in today's lesson, we're starting with indices. The basic thing that you need to understand about indices. Now, the point is that indices is basically the plural of index of an index. So what is an index? So an index, like I've written on the board here, just tells us the number of times a base has been multiplied by itself. The number of times, so an index tells us the number of times a base has been multiplied by itself. So if I have a raised by m, for example, a is the base, right? And m is the index. All right, a is the base, m is the index. So what we basically know as power, right? So yeah, that's the index. So let's say I have 5 squared. So what 5 squared means is that 5 has been multiplied twice. That's it. So that's what I have here. So 5 raised power 2 is 5 times 5. So the 2 is telling us that we've multiplied 5 two times, or that we are multiplying 5 two times. How about 2 raised power 4? So the index is 4, telling us that 2 has multiplied itself 4 times. So you have 2 multiplied by 2, multiplied by 2, multiplied by 2, right? And then that gives us 16. It's as simple as that. So moving away from that, or moving on from that, we'll now begin to talk about the laws of indices. So we start with multiplication law. So what does multiplication law say? So it's just saying that if you have the same base multiplying each other, what we have to do is to add their indices. All right. So if you have the same base multiplying each other, so we pick one of the base and then we add the indices, and then that's going to give us our answer. So in this case, we have a raised power 2 multiplied by a raised power 3. Right. So since both of them have the same base, the base of a, right? So I'm just going to write a, then 2. This times is saying that I should add up the respective index. So 2 plus 3, and this is going to give me a raised power 5. It's that simple. Very, very cool. Okay, so what if I have something like 2 raised power 2 multiplied by 2 raised power 3? Now it's the same thing. So I just pick one of them, 2, right? Then I add up the respective index. So I have 2 plus 3, and then that gives me 2 raised power 5. Now, when you solve out raised power 5, that would eventually give you 32. Okay, but how about a case where I have this one? I have, let's say, a raised power 1 multiplied by b raised power 2. Now, since they don't share the same base, I cannot add up their respective index. No. Alright, so what I can just do here is just normal multiplication from your algebra. So it's just going to give us a1, b2. Now a1 is same as a, so the final answer will be a b squared. I won't be able to express this in this singular form. Okay, so you must really consider the fact that they must share the same base for you to add up the indices to get a particular figure. All right, so that's about the multiplication law. So number 2 is the division law. The division law, or what you can call the division rule, or whatever it is. Now, for our division law, is similar to what we just did for multiplication, just that here we are dividing. All right, so if I have an example, if I have c raised to power 4 divided by c raised to power 2. So what should I do? Okay, since they share the same base, I'm going to pick one, c, but the division sign is telling me that I should subtract the indices from each other. I should subtract the respective index from each other. So I'm going to be having c raised to power 4 minus 2, and this gives me c raised to power 2. That's all. Again, if they do not share the same base, we do not do anything like this. All right. So, sometimes you may have something like this: b raised to power 8 divided by b raised to power 2. Okay. So what should I do here? 8 divided by 2, right? So I'm just going to have b raised to power 4. Nah, it's not like that. So I'm just going to do this is equal to b. Okay, I'm writing b because they share the same base of b, and then the division sign here is saying that I just subtract their powers. So b 8, b raised to power 8 minus 2, then this gives me b raised to power 6. It's that simple. Okay, so is there another example that I have here? If you want to use numbers, so let's say you have what can I use? Maybe 8 raised to power 3. Okay, let's do 8 raised to power 3 divided by 8 raised to power 2. Okay, so I don't do 8. I write 8 first, but I won't do 3 divided by 2 to give 1.5. No, this is going to be 3 raised to power 3 minus 2. Now answer is 8 raised to power 1, which is 8. So if you have something like this, you don't need to punch your calculator, you don't need to stress yourself. I'll be doing 8 times 8 times 8 divided by 8 times 8. This is stressful. So you now be doing 8 cancel 8, 8 cancel 8. So 8 over 1. 8 over 1 equals 8. Now that you've understood this, just do this and get your answer very, very quickly. So there are two more rules I'll try about to talk about. Is it two? Okay, yeah, we start about three more rules basically talk about, or three more laws of indices talk about before I now begin to solve like a little bit complex. We're looking at complex questions, simple to complex questions. That will then apply all of these rules together. But trust me, this is really, really easy. Just try to figure out the principle and then apply it where necessary. Our third rule for today is that of zero index. What does zero index say? It says that once you have a base as raised power 0, then the answer is 1. Once you have a base raised power 0, the answer is 1, except 0 itself though. Alright, so basically this is just saying that if you have 2 raised power 0, this is equal to 1. That's it. Or if you have 1000 raised power 0, it is still equal to 1. 1 raised power 0 also is equal to 1. X raised power 0 is still equal to 1. Finish. So that's what that is trying to like tell you. You now be wondering, where exactly are you going to be needing this kind of thing? In your journey as you continue to study mathematics or mathematical economics or whatever is going to be needing indices, you would see where you can bring this guy in to simplify some things for you and collect like terms and make things easy. Anyway, just know that for now, right? So any base raised power 0 except 0 itself, at least that I know for now, will give you 1. No matter how complex the number is, 1 million raised power 0 is 1. As long as the index is 0, what you have is 1. Now number 4. Number 4. So things are getting interesting. Negative index. How do you treat a negative index? So let's say that you have x raised power minus 2. So what this means, as long as the index is starting with a minus, right, then the entire thing becomes 1. You are going to have 1 divided by whatever you have. Now let me explain it very well. Since this is a minus, so what it means is that this is going to become 1 over x squared. That's all. 1 over x squared. So that's the meaning of x raised power minus 2. Now, I can simplify this guy by using my zero index. So what can I do? 1 over x squared is same as x0 over x squared. Do you agree? Can you see? Right. So x raised power 0 is 1. Yes or no? And using that division rule that we learned from the beginning, so this is x0 minus 2, and then this is x raised power minus 2. So we get this guy back. Okay, so you can see how interesting it can be. All right. So it's not say a particular thing raised power 0 will give you 1. You can just, people need it. Now, since this is x in terms of x, okay, I can just turn my 1 to x raised power 0 so that I can collect like this and make this easier for myself. That's it. All right, so how do you now treat something like this? A raised power minus 5. The same way, we're going to be having 1 divided by a raised power 5. You do not put a minus here anymore because the reason why you're eliminating this minus is the reason why you put 1 over it. So you have a 1 as a numerator, then you have the whole thing back at the denominator with the exception of the minus. You do not need the minus anymore. So let's say I have a question that says for, let's see, I have 6 raised power 2 minus, no, not minus, 6 raised power 2 divided by 6 raised to power 3. From our division rule, so I'm going to be having, this is going to be equal to 6 2 minus 3, which is 6 raised to power minus 1. Yes or no? So from this, we know that 6 raised to power minus 1 will give us 1 divided by 6 raised to power 1. This gives us 1 over 6. Finish. All right. These are interesting, right? So the fifth one, I think that should be the last rule. Raising a power to another power. Okay, no, this should not be the last rule. I think there's one more. All right, the next rule is about raising a power to another power. Yeah. So for this guy, how does it work? There's one more rule after this. how does it work? So I'm going to have, let's say we have a raised power m, then raised power n, something like this. So it's going to become a raised power m times n, and this is going to give us a raised power m n. So whenever you have um, something, a base and an index in parentheses raised by a different index, what you have to do is to multiply the two index together, and then you're going to get, you know, something like this. So let's do an example. So I have 4 raised power 2, then all of this raised power 3. So I'm not going to do 4 raised power 2 plus 3. No. But what this is trying to like tell us is that you have 4 raised power 2 in 3 places. So something like 4 raised power 2 multiplied by 4 raised power 2, then multiplied by 4 raised power 2. So I've proved it for you. You understand? So 4 raised power 2, then raised power 3 is 4 raised power 2 in 3 different places. So I'm going to have 4. Then I can take all of the 2's, 2 plus 2 plus 2. Then that gives me 4 raised power 6. So how does this rule apply? Instead of me to go all of this long way, I don't need to do that. So 4 raised power 2, then multiply by 3 is basically 4 raised power 2 times 3. And then this gives me 4 raised power 6. So that's how you work out when you're raising a power to another power. So I want to believe that is clear for now. So guys, having learned all that we've just learned, so let's talk about exercises. Like let's begin to solve a lot of questions on indices. So I'm going to have exercises. We are doing them together. Then I'm going to have a take home. Cool. So the first one, where is it? Okay. You know that thing when your teacher teaches something very simple and gives you a very, very crazy exam? Um, 3g squared, then all of this raised power minus 2. I know what you're talking about. Oh, yeah. So they're all the same. All our teachers are the same. It's okay. It's okay. So you have a minus c. I just want to write all the questions on the board once and for all. 5, then raised to power 2 divided by minus c raised power 7. Okay, not that it is hard. I hope I'm not solving you. Okay, let's give an assignment. Then 3 number 3 is 1 over 4, 1 over 4, then 8x squared raised power 3, number 4, 8a, I believe you're following, divided by 2 a squared. This is like the simplest of the lot. Then number 5, oh, number 5 can't even contain here. It's looking very, very crazy, even to me. 1 divided by a raised power 4x, then here a raised power 4x minus a raised power minus 2x, then this raised power 0. Okay, good. So solution. So let's begin to break all of these things down into smaller particles. So for the first guy here, number 1, 3g, both of them are the owner of this squared, right? So I will just do 3g square 2, then all of them are raised power minus 2. So you remember that it's just 2 times minus 2 that's going to become. Is that okay? 2 times minus 2. Again, the square is for g, and this square is also for 3. So when I enlarge this, I'll be having 3g raised power 2 times minus 2. That's minus 4. Minus 4. All right. So then this is going to become 1 divided by 3g, which is in brackets, raised to power 4. Yeah, cool. So if you want to simplify it further, then we're going to be having 1 divided by 3 will take its own 4, 3 raised to power 4, and g raised to power 4. Like I said, this square belongs to the two of them. All right. So minus 4 will then belong to the two of them as well. And then 1 over whatever. So that's going to give us 1 divided by 3 raised to power 4 is going to give us 81. 81, then g raised to power 4. And we're done. So that's the answer. So this is different from if the question had been 3 3g squared, something like this, raised to power minus 2. So if you add this kind of question, so this would have been equal to, now you would have done the power on 3 in this place is 1. You have done 3 raised to power 1 g raised to power 2 in bracket like this, then raised to power minus 2. So this is going to give us 3. 1 times minus 2 is minus 2. G raised to power 2 times minus 3, I have g raised to power minus 4. So you can see that things are different here. So when you continue with that, 3 raised to power minus 2. So basically, I just have 1 divided. 3 raised to power minus 2 is just 3 raised to power 2, 3 squared. G raised to power minus 4 is just g raised to power 4. So it should have been 1 over 9 g raised to power 4. So I want to begin to understand those differences if you never really understood them. Right, so it's as simple as that. But always look at it. The index, does it affect all the elements in parentheses or not? So you can see how this one and this one can give you this different answers, and they should give you different answers. Right, so for this other guy, it looks complicated, but it's pretty much simple. So for number 2, this place you contain it, minus c raised to power 5, then 2 is outside, so you can just do 5 times 2. 5 times 2, it says divided by minus c raised to power 7. So this is pretty much straightforward. So you have minus c, 5 times 2 is 10, divided by minus c raised to power 7. This is minus c, this is minus c, so it's easy to collect like terms. So you're going to start with minus c, starts the common base, then 10 minus 7. I'll finish that up at minus c raised to power 3. There's nothing you can do to that. Right, so you can't say c raised to power minus 3. No. Okay, that's not gonna work because the common base is minus c. So the next question is now number 3. For number 3, so we have 3 this way. So if we don't just jump and say, oh yeah, 4 year 1, 4 in 8, 2. No, that would be wrong. Why? Because 8 is also raised to power 3 here. So if you do 4 year 1, 4 year 2, your mathematics is really, really wrong. So what you have to first do is to expand this bracket and then continue to whatever you have to do. So what do I mean? I have 1 over 4 into bracket 8x squared and raised to power 3. So this 8x squared, let me expand it. So I'm going to have 1 over 4 into bracket. Now 8 here is raised to power 1. So this is 8 raised to power 1. Then this is x squared. And both of them on the 3 that is outside. So once I consume with that, I'm going to have 1 over 4 into bracket 8 raised to power 1 multiplied by 3, that is 3. Then x 2 multiplied by 3, that is 6. I still cannot divide this way, as you cannot say 4 year 1, 4 and 8, 2. That will still be wrong. So what do? I can have 1 over 4. I need to expand 8, in 3 places. Or better still, I could just do 8 times 8 squared. You get what I mean? Right? That's this 8 raised to power 1. So that's 8 raised to power 3 anyways. 8 raised to power 1 times 8 squared, then x raised to power 6. So this is going to give me, I can now do 4 year 1, 4 year 2. But this is just 8 raised to power 1. 8 raised to power 1 is 8. Right, so when I continue, I'm going to be having 2 times 8 squared, 2 times 8 squared, x raised to power 6. And this is 2 times, I can't say 2 times 8, 16. No, right? So let's first expand 8 squared. So it is 8 squared is 64, 64x6. Now 2 can now multiply 64 to give us 128x6. Just be careful with the way you move your numbers around. Alright, so it's that simple. Or if you never dare to complicate the whole thing for yourself from the very beginning, so we have just said this would be equal to 1 over 4 Now 8 cube, just get a calculator. As 8, that should be 21, is it 216? 64 multiplied by 8. Or 25, 8 times 4 is what I was saying. 8 times 4 is 32. 8 times 6 is 48. So this would have been 512. So you'd have had 512 and x raised to power 6. This is straightforward, right? Is it 512? Is it meant to be 512? 64, 2, 3, that's, yeah, 512. So yeah, 512 divided by 4, of course, 4 and 5, that's 1, it remains 1. 4 and 11, that's 2, it remains 3. And 4 and 3, 4 times 8, 8, x 6. So you could do it this way, you could do it that way. But sometimes you may not be giving calculators. Maybe I wrote an exam recently, I'm not giving a calculator, so uh, just use your indices and solve the whole thing out. Now, number 4 is the easiest. So you have 8 a 3 divided. Let me change this marker. It's looking silly to me. Okay. So you have 8 a raised power 3 divided by 2a raised power 2. So what can I just do? I can just do 2 here 1, 2 here 4. They can divide each other. They are just numbers. And then the power on each of them is 1. So it's easy. So if this had been 8 squared, I wouldn't have done 2 here 1, 2 in 8, 4. You get it? So that's not going to make any sense. Alright, so but since their power on 2 is 1, the power on 8 is 1, so we can divide quickly. So I'll be having 4a3. Now, the division sign means there'll be a minus. Then this squared here, 2. And by 4a raised power 3, then minus 2. So I have 4a. Finish. 4a raised power 1 is equal to 4a. That's all. So again, I did 2 here 1, 2 in 8, 4 because the power on 8 and 2 are both 1. So if this had been 2 squared and this one was 8, I wouldn't have been able to do that until I first expand the 2 squared to give me a 4. So guys, be careful. And number 5 is so simple, even though it looks so hard. 1 divided by a raised power 4x into bracket a raised power 4x, then minus a raised power minus 2x raised power 0. Something like this. Then I have a bracket here. So first, what do I do? A raised power minus 2x times 0. This power times it, because this 0 belongs to only this, the way the whole thing has been done. If this 0 had been outside of here, then it would have belonged to everything inside of the parentheses. Since it belongs to only this, so that is basically going to give us 1 over a raised power 4x into bracket a raised power 4x minus 0 multiplied by this is 0, and a raised power a raised power 0 is going to give us 1. Or better still, even before multiplying it, a raised power minus 2x and raised power 0. We said anything raised power 0 is 1, so this is just 1. That's all. Okay, so looking at it, you cannot divide. Okay, you can say a raised power, this is raised power. You can say a raised power 4 here x1, then a raised power 4x. No, because if you are trying to do that, then that means you also have to divide 1 by a raised power 4x. So it doesn't make any sense. So this is how you're going to leave your answer. Or if you feel like expanding, so you could just do a raised power 4x minus 1 divided by a raised power 4x. So you can see that it is very easy. There's nothing else that you can do from this point. So except you want to, but for some people you want to break it down for no reason. So having something like this, like I said, everything here, right, belongs to, okay, this one, the denominator here is meant to divide everything that's in this bracket, that is, everything here serves as the numerator. This is the denominator. So if you want to like still expand this, it will just become a raised power 4x over a raised power 4x, then minus 1 over a raised power 4x. So this will cancel this. We have 1 minus 1 over a raised power 4x. Here too, there's nothing else you can do. So you can just stop there. You don't need to like be doing all of this paparazzi. So after this, if you have any question, you can leave them in the comment section. So I want you guys to practice really well. Practice all of these things again. And once you master it, then you are very good. So next thing is your assignment, and then we move to a type of indices in the next lesson. So here we go with the very beautiful assignment. So there are just 5 of them. Simplify them to their lowest form, just like the exercises that we did. So A, 7 raised to power 8 times 7 raised to power minus 8. Then B, 3 into brackets 3 raised to power 3 over 9 a raised to power 7. Then x raised to power 0 times 3x raised to power minus 1. Then C is all of this, a raised to power minus 1, open brackets, ry squared. So the square is just for y, over 4ry raised to power minus 3. In this case, again, the minus 3 is just for y. Then close the bracket, raised to power 0 times 8x. Then the whole of this thing raised to power minus 2. And D is clear enough. Then E is what it is. So for E, you would likely be having don't let me hint you. So let's leave it that way. So let's see what beautiful things you guys can come up with. Now to submit your assignment. So see you in the next lesson. Bye and have fun.